Hi, welcome to Unit 2, Lesson 1, Part 2 video. If there's anything that you still need to review from earlier in these notes, you would have to review the Unit 2, Lesson 1, Part 1 video. We are going to start Part 2 right now. We left off with even versus odd functions. I don't care about the algebraic approach as of right now. You'll learn that in pre-calculus, okay? I just want you to cross this out because I'm still going to use this space underneath it, so don't put a big X to that side. I am more concerned about the graphic approach, okay? You can tell a function whether it's even or odd based on its graph. So let's start with even, okay? If a graph is even, it would look like it is a reflection about the y-axis. Okay, the graph would look like it's a reflection of itself across the y-axis. Now, let's not forget the y-axis is the one that goes up and down. Okay, my y-axis is here, my x is here. The most common form of a even function is a parabola. It's not the only one, but it's the most common. If I come down like this, then I come up like this, there you go. That looks like a perfect reflection right across the y-axis. But Visca, how can I tell? Well, you look at this point and you go, blah, 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 blah. Maybe it's 3 spaces to the right from the origin. Blah, 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 blah. That would be 3 spaces to the left. Every point would be a reflection onto the graph on the other side, which is fine. This point, blah, 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 right there. Good. Boom. Even. That's the easier of the two to tell. Okay? Odd is not hard to tell, but even is, it just jumps out at people more. Okay, so let's take a look at odd. How can I tell if a function is odd? By looking at its graph. It is also a reflection. No, it's not a reflection about the x-axis, because most people think, oh, if even is a reflection over the y-axis, odd has to be a reflection over the x-axis. No. It is a reflection about the origin. All right. Now, let me give you an example of this right here. Odd. Let's erase some of this here so we got some space. Here's my x-axis. Here's my y-axis. Something that looks like this. Up, across, up. All right, that's an odd function because it's reflected about the origin. The origin, in case you didn't know, highlighter, is right here, right in the middle. Okay, if I reflect every point through that yellow highlight, which is the origin, it will reflect onto itself on the other part of the graph, meaning this point here, look at that, bang. This point here, bang, perfect. Okay, that's odd. So, let me give you another example. So it goes like this, like this, like this. That clearly does not reflect over the y-axis. Does that reflect through the origin? If I pick this point here and go, oh, shouldn't it be right here? Should be, it's not. That doesn't reflect across the y-axis or the origin. That means it's not even or odd, and that's okay, because sometimes graphs are neither. Okay, it's going to be even, it's going to be odd, or it can be neither, and that's fine. Okay, those are our 3 choices. So now we have 4 functions here. F of x, g of x, h of x, and k of x. And we are going to tell if they are odd, even, or neither. Now, h of x and k of x, my 2 on the right, seem easier because they're graphs. In fact, we can almost tell what they are, but we'll wait. Let's take a look at our equations. But Visca, you didn't show us how to do it algebraically. Ha ha ha. Hold your horses there, buddy. We have something called a calculator. If I graph this in the calculator, I know that would cross, my y-intercept is 4. So let's say this is 4 right here. It's my y-axis. And it has a slope of 1. We'll go here, go up 1 over 1, up 1 over 1, up 1, and so forth. The line would look something like that. Okay? That clearly is not a reflection over the y-axis. Because if this part in quadrant 1 was reflected over the y-axis, it would look like that. Okay? So that's not a reflection over the y-axis. Is it a reflection over the origin? If I pick this point, it should be there. It's not a reflection over the y-axis or the origin, so it is neither. That's fine. I told you something can be neither. All right? Let's graph g of x. (3x squared). I know it's a parabola. It just rises quicker, right like that. And without even batting an eye, you should know that that's a reflection over the y-axis, which means it's even. Let's take a look at h of x. All right, well, it's a parabola, but does it reflect perfectly over the y-axis? It does. If I pick this point here, it reflects right here. I pick this point here, goes reflects right there. Good, perfect, even. The even ones are easier to tell. All right, now let's take a look at k of x. That is obviously not even. So it's either going to be odd or neither. Does it reflect about the origin? Let's pick this point right here. Badu, 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 badu. Oh, it does it. It's right there. Okay. Let's pick this point right here. Badu, 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 badu. Oh my God, look at that. It does. Good. We're good. We're good. That is definitely odd. Okay. Now another way, and it would have to be drawn out kind of, accurate. But another way is if I take this graph, it goes here, runs through, goes down like that. Perfect. And I rotate that about the origin 180 degrees, right around that point. I'm putting that black dot. If I rotate this 180 degrees, boom, it would reflect right on itself. You see that? It would lay right on itself. If I rotated 180 degrees about the origin, that's almost the same as reflecting it about the origin. Okay? That is nice. Look at that. Bam. Bam. All right? So that's another way. I mean, some people like to rotate instead of reflect. That's fine. But you start to get the feel of these things, and you can tell just by looking at the graph. Even if you only have the equation, you can still graph it, and you can still tell whether it's even, odd, or neither. All right, the dreaded word problem. The weight W in pounds of a patient during a 7-week illness. Oh, man, it's not a happy question, is it? Is modeled by the cubic function W of n equals 0.1 n cubed minus 0.6 n squared plus 110, where n represents the number of weeks since the patient became ill. Oh, man, that's really sad. Oh, it makes me sad. A says, sketch a graph of the person's weight over the course of 7 weeks. Well, first of all, most of the time our table is written in XY form. Okay? If you did not know that, well, look, your equation is y equals, right? Y is your W, and all the variables in your equation are typically your x. So n would be your x. Of course, your independent variable, or your x, is always the one in parentheses anyways. So you can tell that. Now, what should I do if I want to graph something and I have a calculator in my hand? All right, obviously they want us to fill this table here. So I'm going to put this equation right into our calculator, and I went ahead and did that. Hopefully it's still there. On. There it is. All right, I have typed in 0.1 x cubed minus, just so you can see it, and it'll give you time to catch up, minus 0.6 x squared plus my 110. I want 0 through 7. And I'm going to put the y values for the corresponding x values, okay? So I'm going to look at my table. 0 is 110, okay? Notice I want through 7, and I only go down to 6 here. So I'm going to go 1 through 6. And remember that 0 was 110. So I'm going to put this right over here, bam. It's kind of close. Let's move this. It's okay, somewhat close. All right, move this out of the way. I'm going to fill this table in. I know that 0 had 110. 1, and all I'm doing is going through the table. 1 is 109.5. Okay, 2 is 108.4. 3 is 107.3. Then we go 4, which is 106.8. 5 is 107.5. Oh, good. They actually recorded gaining weight here. Oh, good. Thank God. I was a little worried there at first. When someone starts gaining weight again, it means they're getting healthier most of the time. Okay. 6. Oh, we're back to 110. That's where this individual started. You know, oh my God, they got to stay off the jelly donuts because they even put on an extra, pretty much, 5 pounds. I almost wrote a 5 there because I was thinking 5 pounds. Okay, so ho, it's December right now. It's the holiday. You got to stay away from those, hot cocos and eggnogs and jelly donuts and Christmas cookies. Oh my. Anyways, enough of my fantasies about food. Let's talk math again. Move this back over here. So they want us to sketch a graph of this person's weight. All right, so we're going to sketch these. Now, look at the graph they give us, okay? They give us a graph. Okay, if I said the bottom was 0, it looks like I have 1, 2, 3, 4, 5, 6, 7, 8, 9 tick marks on my x-axis, which is fine because I got to go from 0 to 7. So I can go by ones. I'm fine. 1, 2, 3, 4, 5, 6, 7. If you want to do 8, you can. You can do 9 as well, but we only need through 7. Now, x represented what? The number of weeks, correct? Because x is our n, and n represents the number of weeks since the patient became ill. So we'll just call this weeks. If you want to put since patient became ill, you can. That would be even more accurate. Weeks, I don't like writing since patient became ill. All right. Now, the problem here is if I count my Y tick marks here, 1, 2, 3, 4, 5, 6, 7, 8. And I'm looking at my Y, which is W, which is weight. So I'll do W, which is weight. Sorry, it's messy writing. It goes from 110, the lowest. No, actually, it goes to 106.8 is the lowest. And it goes up to 114. So I can't go, you can go from 0 to 120 and divide. This is what I would do. I would go from 100 to 114. Listen to me here for a second, kids. 100. And then I'm going to count by twos. 102, 104, 106, 108, 110, 112, 114. Now, there's a little something that you might not have seen since Algebra 1 or even Math 8. I'm not sure where exactly this starts. Math 7 with Common Core. Probably kindergarten with Common Core. I'm kidding. Anyways, these tick marks are all even from 100 to 114. But from 0 to 100, that is not the same increment. So it's off. So do any of you remember seeing that if the bottom is kind of like chopped off, like obviously from 0 to 100 it is not there, okay, at least not according to this same scale we have on the left. We do this kind of like accordion. It's like a straight line that's crunched together and angled like. That just means that's a whole bunch of filth and flaring that we're not going to use, but we recognize that the numbers 1 through 99 fit in between there. They are just not to scale. That's all that means. Okay? So if you were to see this on a test, and I'm telling you, on the test, they want to expect you to do that on your own, but they might give you a graph that has that there. Okay? And all that means is, look, that's, yeah, 1 through 99 are there. I understand it's not the same scale as 100 through 114 because they go by twos, but it's there. It's just all munched together. That's why that munched together line is right there. Let's plot some points, shall we, kids? 0, 110, and now I'm going to use this table. 0, 110. 0 goes to 110, which would probably be right at 110. 1, 109.5, so that's just slightly lower than 110. We did this one. 2, 108.4, so 2 is going to be closer to 108. That's probably, maybe just a hair above it. 3, 107.3. Okay, so that's going to be in between 106 and 108 is 107. Yeah, I know, mind-breaking, ground-breaking, mind-boggling, I should say. 4, 106.8, so that's close to, that's just under where we put our 3 points, okay? 106.8 is just underneath our 107.3. So I go to 4, and I'm going to go something just barely lower. Now we're going back up. 107.5 is for 5, so that's almost just right where our 3 dot was. 6 is back to 110. Thank God. This person seems to be healthier. They were at the weight they started at. And guess what? Put down the jelly donut because you're pretty much at 115, which is above 114. So we stop at 114. We're going to go slightly higher than it. And there you go. So if they want us to sketch a graph, we're just going to connect all these dots. Okay, they're sick, they're sick, they're sick. Oh, man, they're looking really thin. Oh, hey, they're starting to gain weight. They look healthy again. Holy cow, cut out the carbs. You big. I'm just kidding. 115 is not big. So we're going to go down here, and we have a beautiful graph here. I love it. What is the least the patient will ever weigh, and when did this occur? So if they're asking us this, that's our W, which is our Y value. And when did this occur? What week? That's our number week, which is the same as our X value. So we need our Y value and our X value. We need a coordinate. Okay, we need an X and a Y when they weigh the least. That screams minimum to me. Now on the table, our minimum occurs at 4. But let's take a look at our graph and see if it dips slightly below and comes back up. And this helps us practice using the min function. So if I go to my graph here, and let's turn this bad boy on the computer instead of pressing the screen 8 times. And I want to, I'll do this so it's easier for you guys to see if you're looking at it on a phone or whatever. I want to look at my graph. I graph this, and right now I see this thing that does not look like what we have. Okay? I'm going to change the window of my graph to represent the exact window I have here. My X's go from 0 to 8, and my Y's pretty much, I don't care about this scrunched up accordion, they go from 100 to, and I got to make sure I don't just go to 114 because this Y value is slightly bigger. I want to go to 115, okay? So I'm going to make my window on the calculator exactly what it is on the paper. So let's press the window button. My X's are going to go from, move that, 0 to 8, and those are by 1s. That's what that means. The scale is by 1s. My Y's, I'm going to go from 100. Let's go to 116. And we're going to go by 2s. Yes, you can make this you said 114. You can make that 114. But if I stop at 114, I'm not going to see 114.9. That's slightly higher. So I'm just changing that. And if I graph this, I just see exactly what I have. Ooh. Not that I like to, brag or anything, but hot dang. Let me do this. I got to do this. Boom, 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 boom. And out to here, 0 through 8. Did I do 8? Would it be like that? It would be. Oh, my Lord. That is almost perfect. And, again, I hate to brag, but hot dog. God, people, when we're good at math, we're good at math. Look at that graph. Let me just crunch that a little bit more. Come on, there you go. That is, like, spectacular. Look at that. People, we good. We're good people. We are good. So they want the minimum, right? Where do I go to find the minimum function? I go to second trace, because above trace in blue it says calc. And I want the computer, or the small mini computer, which we call calculator, to calculate our minimum, which is choice 3. Okay? Now this is where I got to make a bow tie around my minimum. So the, yeah, I'm going to say computer again. The calculator is telling me, well, go left. Well, our minimum is about here, so I want to go left of it. There you go, and I hit enter. Now the calculator is saying, well, what about right? Okay, so now I'm going to go right over here. I hit enter. Now it makes my bow tie, and what it's going to do, it's going to guess. It's not going to guess the minimum for everything. It's just going to guess my minimum from where I put my left, in between these two bookends, so to speak. It's going to guess my minimum in this little arc right here. Guess, faux show. And there it is at 4,106.8. Our table was actually correct. I love it when everything works out. So here we go. 4,106.8. So the coordinate is nice, but they're not asking us for a mathematical coordinate. They're asking us what is the least the patient will weigh. So we need to answer that question. I don't want to say 4,106.8. When you ask a doctor what's the least a patient will ever weigh and when is that going to happen, he's not going to say 4,106.8. He's going to say they will weigh 106.8 pounds at week number 4. That's how he's going to answer it, because he's a professional. And because you know what? You are on the cusp of being a professional mathematician. That's how you will answer that. If they just wanted to know what the midpoint was, 4,106.8 would be fine. Sorry, I got a little worked up there, like I was going to yell at somebody. Now, predict the patient's weight after 20 weeks, or after the 20th week. That means my n, or my x value, which is number of weeks, will equal 20. So I take the original equation minus 0.6x, or n squared, plus 110, and I put a 20 in for those. So 0.1, 20 cubed, minus 0.6, 20 squared, plus 110. I can do that 2 ways. I can actually type this in the calculator and hit enter, or since I already have my graph in, I could look at my table when x is 20. So I'm going to go down here. 670. Yeah, because let's not forget, at 19 weeks, this model predicts 579.3 pounds. This is the week. This is the weight. Okay, so at 20 weeks, 670 pounds. So we're going to do this. Sorry, I don't mean to laugh. That's terrible of me. 670 pounds. Doesn't seem reasonable. Heck to the no. No, it doesn't seem reasonable. 670 pounds? I had kids in class, I kid you not. Yeah, what about my so-called 600-pound life? I'm like, stop that. Stop that. Stop that. Because those people have a show, because that's rare. That is not the norm. Someone who weighed, okay, when this whole sickness started, at week 0, they weighed 110 pounds. For them to balloon up to 670 pounds is not reasonable. It didn't say, is it possible? It is certainly possible for a human to weigh 670 pounds. Otherwise, they wouldn't have such wonderful shows on TLC like that. But it is not reasonable. Big difference in the question. I think we are, oh my God, we are. We're done. I'm going to miss you. I'm going to miss you. But you know what? You can buy me a Christmas gift, and you can leave a comment underneath the video, like, where do I send this Christmas gift, Visca? And I'll give you a P.O. box, because you know what? If I give you my home address, yeah, you're going to stalk me, and it's going to get weird, and then I got to get a restraining order. It's going to be crazy. But I do like Christmas gifts. All right. See you later for Unit 2, Lesson 2, because that's coming soon. See ya.